Hi, this is Maggie. In this video we're going to talk about two other kinds of expressions that evaluate to the Boolean literals true and false, Boolean variables and expressions with Boolean operators. We'll begin by discussing Boolean variables. This program obtains a number of stars from the user and then uses an if statement with a relational expression to confirm that the number is greater than 0 before dividing into 360 and printing the result. We have two variables in this program, the integer variable numStars and the float variable angle. A variable is a way to reference data that we will need to use later in the program, or another way of putting it is, a variable is a way for Python to remember a value for later use. A variable can reference any type of value, including a Boolean value. There are only two Boolean values, or literals, true and false. Here in the console, I can write flag equals true. Note that the literal Boolean values begin with uppercase letters. And if I then ask Python to evaluate the variable flag, it tells me true. So I can store a Boolean value in a variable. I can then use that Boolean variable in a test. It will evaluate to true or false. I can write, again in the console, if flag colon, and then I can print the test is true, just so I have a conditional line. And when Python evaluates that, it prints the test is true, because the condition, which is the variable flag, evaluated to true. Now let's put this to use in a program. Back in my program that obtains a number of stars, I can use a Boolean variable to store whether the value the user gives me is valid or not. I'll first annotate a variable to store that value in, is valid colon, and then bool is the name for the Boolean data type in Python. Now, after I obtain the number of stars from the user, I'll set is valid to true if the number is a valid number, one that is greater than 0, and I'll set is valid to false otherwise. The easiest way to do that is to write is valid equals numStars greater than 0. Remember the way an assignment statement works. The expression on the right is evaluated, and then the value is assigned in the variable on the left. The expression on the right is numStars greater than 0. That is a Boolean expression that will evaluate to true or false. The result of that, either true or false, depending on what the user entered, will be referenced by the variable isValid. I can then use isValid in my test. I can write if isValid colon, and the conditional code will execute if true has been stored in isValid, and otherwise the else code will execute. Now generally we use a Boolean variable if we need to reference the result of that test in more than one place in our program. For example, if there are many places in the program I need to test if the input was valid before executing some code. Or if we're setting the Boolean variable in more than one place. For example, if we're obtaining a number of inputs and we're going to set the variable to false if any one of them is bad. Beginning programmers generally find Boolean variables a little confusing, so work through some examples and perhaps step through code with Boolean variables in the debugger and predict what the variables will evaluate to. Try to get comfortable with the idea that you can store true or false just as you can store a number. Now we can also write more complex expressions than we have written so far by using the Boolean operators and, or, and not. These operators take Boolean expressions as operands rather than numbers or strings. For example, if we want to test that a value is in a range, we can write an expression such as num stars greater than 1, and then join that with an AND to num stars less than or equal to 360. The AND operator is the word AND, all lowercase letters. This entire expression will evaluate to true only if both expressions joined by the AND evaluate to true. So only if num stars greater than 1 is true and num stars less than or equal to 360 is true. If either expression evaluates to false, then the entire expression evaluates to false. This can be succinctly communicated in a truth table, a table that shows the possible operands to the AND the outcome. If both of my operands evaluate to true, the entire expression A and B will evaluate to true. But you can see that if either operand is false, or if both operands are false, the entire expression evaluates to false. We can also join expressions with an OR if we want the entire expression to be true if at least one of the conditions is true. Suppose we have variables age and height that we will use to determine whether a young person is safe on a ride at an amusement park. We can write the expression age greater than or equal to 12 or height greater than or equal to 42, for example, which will evaluate to true if either of the expressions are true or if both are true. The only way that evaluates to false is if both expressions evaluate to false. As with AND, the OR operator is the word OR, all lowercase letters. Here is a truth table for OR. You can see that the entire expression evaluates to true as long as at least one operand evaluates to true. And it only evaluates to false if both operands are false. The final Boolean operator is not. The not operator takes only one operand, again, a Boolean expression, and it negates it. So if the Boolean expression evaluates to true, not expression evaluates to false. I recommend that you use not in front of Boolean variables only. So for example, we might write if not is valid, but we don't write if not age greater than or equal to 12 or height greater than or equal to 42, because it becomes very hard to read an expression with a lot of relational and logical operators in it, particularly when it is negated. The better way to negate a relational or Boolean expression is to complement it, or write the expression with the opposite truth value. It's relatively easy with the relational operators. Less than is the complementary operator to greater than or equal to, and vice versa. Greater than is the complementary operator to less than or equal to, and vice versa. And equal to and not equal to are complements. With the Boolean operators and or, we used De Morgan's theorem to complement them. The complement of A and B is the complement of A, which I will write as A prime, or the complement of B. And the complement of A or B is the complement of A and the complement of B. For example, the complement of our range check from earlier, num stars greater than 1, and num stars less than or equal to 360, is num stars less than or equal to 1, or num stars greater than 360. That's the complement of num stars greater than 1, num stars less than or equal to 1, and the complement of num stars less than or equal to 360, num stars greater than 360, joined with an or instead of an and. If you draw those two expressions on a number line, you'll see that they represent two complementary sets of numbers. If a number is in one set, in other words, if it makes one expression true, it will not be in the other set. You might be wondering where the Boolean and relational operators fit into the operator precedence. Or you might not, but for example, with an expression like not age greater than or equal to 12 or height greater than or equal to 42, if not has a high precedence, then it will negate the expression age greater than or equal to 12. But if it has a low precedence, it will negate the entire expression, age greater than or equal to 12, or height greater than or equal to 42. So it matters. So we'll revisit the Python order of operations table at python.org and take a look. Here's the table. And remember, it reads low to high precedence, top to bottom. The relational operators are all at the same level of precedence, which is lower than all of the arithmetic operators. So we are building to the bottom of our precedence table after addition and subtraction. The next highest precedence is not, which means we'll need to enclose a compound expression like age greater than or equal to 12 or height greater than or equal to 42 in parentheses if we wanted to negate the whole thing with a not. But we wouldn't. We'd complement with De Morgan's theorem for readability. And then and has the next highest precedence, followed by or. If you are writing something with both an and an or, which sounds kind of messy, then you might need to enclose parts of it in parentheses to force the order of operations you want. Boolean logic is incredibly important in programming. The expressions that we write determine the flow of control in our programs, so it's crucial that we get them right. Practice with this and test your expressions thoroughly by testing values within, without, and on the edges of your ranges. Always predict the results and confirm. Don't just accept your program's output and assume it's correct. Once you're confident writing Boolean expressions, you're ready to move on.